Alrighty. Okay. So we did the Roman numerals yesterday. Hopefully everyone can find time to review them quickly, because yesterday and today's material you need to understand it well in order to be okay with tomorrow. You need to review it in time for tomorrow. Otherwise tomorrow is going to be extremely confusing. So we did the Roman numerals. Let me just see where I am here. This what's next? 2.2. I'm only doing two number systems from history. The other one is the Babylonian number system. And I picked these two because for the Roman numbers we do see in certain places today still. And the Babylonian one still has a role in our lives today. So they are relevant number systems to look at before we move on. Now the Babylonians had different problems. They didn't have any paper-like substance to write on. All they had were clay, and they could make clay tablets and make indentations in the clay. So I have a little 1-minute video to play for you first, and then we'll talk more about it. I can't get the speakers to work, so hopefully this is loud enough. Try our best.
All you need is a small piece of clay about the size of a golf ball or a table tennis ball, and to squash it out into a small disc. Here's our clay tablet ready to use. A small stylus. I've just cut mine from a piece of dowel, but in the old days I believe they used to use reeds, and then they used to cut timber much this shape. They used to draw lines, so I'll just draw some lines here quite a distance apart. They used to be write a lot smaller, of course. And believe it or not, for all the sophistication of their number system, they used just two symbols. One of them was this one. Just poke a small mark into the clay. That would be the number 3. And they kept going 4, 5, 6, 7, 8, 9. Easy. The next symbol they used was one like this, which represented 10. And they could make 30, 40, 50. The number I have represented there is in fact 59. If they wanted to represent the number 23, they do 1, 2, and 1, 2, 3.
All right. Just a little introduction to see how they did it. Whoops, not repeat. Loop. No need for a loop. Thank you. That's all I have. Wrong button. Okay, so of course we are not gonna. It'd be nice actually if we all had clay tablets to play with, but limited resources. How do we write these numbers down to make them look similar? So the quantity 1 will represent by something that looks sort of like the little wedge they made. It's my best attempt. And then the quantity 10, 1, 3, 4, 5, 6, 7, 8, 9, 10 is represented by something like that. Different people have different ways of writing these. This, in my opinion, is the one that's sort of closely representing the shape that you'd see on the clay tablet. So, like he said, if we want to write the number 23 using in the Babylonian number system, I'd have 2 10s and 3 1s. We do make them a little longer. 23. And they only had those 2 symbols. Because you don't want to change your stylus to make new symbols and then swap out and make more symbols. You only have the one. And they want to be efficient in how to write them, so they simply want to angle it in different ways to make their number, to write down all their numbers and all their calculations. So they only have these 2 symbols. So isn't that nice? Only 2 symbols. Compared to the Roman ones where you have to memorize a fair number of letters and pairs and stuff, there's only 2 symbols. Yet they built a thriving civilization with just these 2. Trading, all kinds of things, all kinds of calculations that they were able to still represent all their numbers. So let's pick another example. Let's go with something like 47. How would they represent that quantity? So I usually have 3 of the 10s sort of stacked, and then the other one a little bigger beneath that. And then 7, we do 3 in a row. 1, 2, 3, 4, 5, 6. And the last one's a little bigger, if there's only 1 or 2 left. 47. Only 2 symbols, though. That's kind of good news. What else can we represent? Oh, I'll go backwards. I'll give you a Babylonian number, and you tell me what the number is in our language. Oh, sorry, that's not good. See how easy it is? Very easy. Very easy.
Yeah, something will happen.
I'm setting you up.
Yeah.
34. There's nothing to it. Literally nothing to it. Well, okay, there's something to it. 2 symbols. 2 symbols. Any questions on this basic setup? Very easy. Very easy. All right. Now, if you Google these things, different ways of writing these, from what I found, this is the closest representation for what you see on clay tablets. And the nice thing is that a lot of information is known about the Babylonians because the clay tablets were preserved very well. Not like paper, which will break easily. The clay tablets that were found were very clear and easy to decipher. So, let me see, where was I here? This one. I missed my line. The largest number that they wanted to represent was 59. What would that look like? Well, he did it on the clay, but let's do it again. 3, and then 2 10s slightly bigger beneath that, and then 9 1s. That's ugly, sorry. Sort of connected, 3 rows of 3. So the more ones I have, the smaller they become, and I stack them. If there were just 3, then their tails are a little longer. 59. That's the largest they wanted to go. Because they don't want to make too many of the same symbol over and over, and they only had 2 symbols. So it was a little restrictive in that sense. Now, what did they do when they obviously needed to represent larger quantities? for numbers larger than 60, for numbers larger than 60, they said, well, let's just use a place value system, where now I'm representing my number with two places. Here, on the left one, I'm going to count the number of groups of 60. And then I'm going to count what's left and represent that there. For example, if I want to represent the number 75, I break it up and say, well, that's one group of 60. I can't fit in any more 60s. What is left? 15. So I break up the number according to 60s.
Sorry, would you mind going over that again? Sorry, I didn't write down.
They decided on the 60.
Okay.
For various reasons. 60 is a nice number. It can be divided by many numbers. So they decided on the 60. So they said, well, we're not going to go higher than this many symbols. 5 10s and 9 1s to make 59. That's as high as we're comfortable going for a single representation of a number. If a number is larger than 60, then we're going to split it up into two places. The left place is going to count how many 60s I can fit into that number. And then the next one is going to count what's left. So 75 can be split up into one group of 60, and 15 will be left. So then that's simply going to be a 1 space 15. So the space indicates that it's a two-place system, and the left one's smaller than the 10 anyway, so you know it's a new place. And because there are two places, I'm counting 60s and 1s, essentially, whatever is left. Sort of the unit place. The unit place. Another example. Let's go and count 156. Now I have to first see how many groups of 60 can I fit into that. So I want to write this first, and then convert that, this 1 as its Babylonian representation, this 15 has its Babylonian representation. So how can I write 156? How many groups of 60 can fit into 156? 2. So then I have, how much have I used so far? 120. So how much is left? 36. So I have to have that breakdown, not minus, always plus. I have to have that breakdown, and then I see, okay, because this number is large, I'm going to have a two-place number in the Babylonian system. First place is 2 space 36. Two places. Number of 60s, number of 1s, if you want to call it that. Let's go a little bigger. Let's go with, give me a random number in the thousands. Not too big, low thousands.
1,152.
1,152. Now I'm justified to maybe let my calculator help me. It's totally fine. Let your calculator help you and say, what is 1152 divided by 60? Well, by the definition of division, the answer would tell me how many groups of 60 I can fit in there. That is exactly what division means. How many groups of 60 can go in here? Divide 60 into that. What does the calculator say?
18 times.
What exactly does the calculator say?
19.2.
18.2?
No, 19.2.
19.2. So that means if I were to do it by hand, I would get an answer of 19 with a remainder. Something's left over. It doesn't fit in perfectly. But that's okay. I can say here then there can fit 19 groups of 60. This is my multiplication symbol. You can write it times if you want to. How much have I used? Well, then I go to my calculator. You can do it by hand too. You can use the calculator if you want to speed up. You can then say, what is 19 times 60?
It's
1140.
1140.
So I then clearly have 12 left. You don't have to use a calculator. You could also have said, well, I'm going to do long division because I don't have a calculator. 1152. It's just a little slower. So then 60 doesn't go into 11. 60 can go into 115 once. 1 times 60 is 60. Take that away. I have 55, and I bring down the 2. Remember? Good memories of long division?
Yeah,
Memories of long division. You have to, I'll tell you honestly, you have to have a very positive outlook when it comes to long division. Because kids do not enjoy it. It has the word long in it. It's doomed from the start. You have to sort of go over the top with your excitement about long division to fight their negativity. That's my experience. 60 goes into 552. I don't have a calculator. 6 goes into 55 how many times? 9 to get 54. So 9 times 60 is 540. Take it away, I have 12 left. That's too small for a 50. That's my remainder. So you have options. You have to be able to do that. But we're going to do it in the next module anyway, so don't worry about it now if you don't want to. It's going to be good stuff. Next module. So you can use a calculator, you can do it by hand, whatever works for you. Either way, I have to break up the number in terms of 60s. Whatever you prefer. So, then in the Babylonian system, I would have 110 and 9 ones. That's 19. Space, 12. And that's the representation for 1152. 19 groups of 60 and 12 ones. 12 units, 12 left over, whatever you want to call it. Any questions on how that works, how that is built on a 60 number? Yes?
If the first place digit goes over 60,
No, we'll get to that.
never mind, no question.
One at a time, one thing at a time, right? I don't want to overwhelm anyone. Now, an issue before that issue, one issue is, well, I said I can only have 59 in one place, so numbers will eventually get bigger. What do we do then? But before that issue, how do I represent the number 60 itself? Because if I write this, it looks like a one-place number that looks like the number 1. So I have to emphasize that it's a two-place system, and this counts the number of 60s. So in our language, this would be one group of 60 plus nothing left over. But they didn't have a number. They didn't have the concept of 0 as a number. That came in much later. Only in India did they actually start thinking of 0 as a number. There was no number 0. There was, however, the concept of an empty place because of this. I have to have a new symbol to represent that there is a place, but it's empty. So they turn their stylus a little bit, and they make two little triangles on the side, sort of diagonally, to indicate, I think they have a little tail, to indicate, well, there is a place, it's empty. It's empty. There is no number 0. They didn't have any need for a number 0. So now this empty place holder, if you will, now shows that I have a two-place number, one group of 60, nothing left over. So that's the representation for the number 60. Any questions so far? So it is slowly building, yes, but
So the number 60 is the
one
symbol
group of
with the
60
line.
and an empty space.
Oh, just the empty space. The lines aren't.
Oh, no, sorry.
Yeah.
This is just for indicating that I have two places.
Yeah.
Yes. The lines are just for me to be aware of it. It's not part of the notation. It's not part of the writing. Any other questions? Manageable? Still with me? It's going to be easy. But I do have this little problem that they now fixed. They didn't want a new tool to make a new symbol. They just want the stylus and just angle it a little bit. Because now and then it comes up. It doesn't come up that often. Okay. Now the other question is, so we can only have up to 59 in a single place. So up to this point, the largest number seems to be, the largest number that we can have is 59 in one place, 59 60s, and another 59. Now this seems a little slow to write 59, but remember, in their time with their clay tablets, they just press it. It's much more efficient. We don't have clay, so it feels a little slower than it actually is. So that's 59 60s plus another 59. That's the largest I can go with a two-place number. You may need to practice these symbols a little bit. What is that? 3,599. What do I see if I now add 1 to... Not necessary, all right. If I now add 1 to that. So I have the next number in the sequence of numbers. Now I have 3,600. In terms of 60s, what is the link between 60 and 3,600? Let me rephrase that. What is the link between 6 and 36?
Times itself.
Times itself. Times itself. 60 squared. So I've now filled each position if I add 1 here, well, technically 1, then this place is full, there's no space, everything rolls over, and I have this quantity. So we're now going to shift to 3 places. This one will count the number of groups of 60 squared. This one, the number of 60s. And this, whatever's left. Think of it this way. It's exactly the same as our decimal system. Except we work with tens, where they work with 60s. What is the biggest 2-place number in our decimal system that I can make? 99. What happens when I add 1? This guy's full, this guy's full, I need another place. It's exactly the same. It's exactly the same. Okay, well, it's not exactly the same, but it's extremely close. The only difference is our decimal system works with tens, groups of tens. This is the ones that's left over. This is the number of tens. This is the number of hundreds. What's 100? 10 squared. It's the same system. It's the same. But in 60s. Does everyone see that it's the same? All right. So it has relevance. Like I said yesterday, I'm stepping out of my comfort zone, looking at place value systems a little bit more critically and objectively, and then come back and see, oh wow, this is actually how my number systems work. All right, and I can now keep going, just like I would here. If I had another place in the decimal system, what would that represent? The number of
10 cubed.
thousands or 10 cubed. Then I can keep going like this, however big my number needs to be. So, in the Babylonian system, the only difference, apart from the 2 little symbols, that I have is, I have as many places as I need. Those will be what's left. Those will be the 60s. Those will be 60 squared, 60 cubed, and I keep going depending on how big the number is. Now, we're not going to get crazy with it. Usually, 60 cubed is okay. Nothing really much further than that. But it is there if you need, if you have a number that big. So usually we'll hover around these 2. Any questions on the similarities and differences between the numbers that we're so used to, we don't even think about them anymore, and the Babylonian number system? Any questions? Still easy? Still okay? I think so. Now, again, as with yesterday, there are only 2 questions you need to be able to answer. Isn't that nice? One is convert one way, the other convert the other way. So we'll go Babylonian to decimal first. That's probably the easier one, but it's marginal. Let's do, I'll stick to around 3 places. No, let's not do that one. What is that number in our language of decimal numbers? So again, it's not the same as Roman in that you just write down the answer and you're done. There may be a little more work required. So I see I have 3 places. So I'm counting what's left. The 60s. I'm going to write the S there. the number of 60s and the number of 60 squared. So that's as high as I go in this number. So this in decimal is 2 groups of 60 squared plus 10 and 4 is 14 groups of 60 plus 10 and 5, 15 left. You don't have to do it by hand. Let your calculator find the answer, just for the sake of efficiency and speed. You also don't need to worry about this. After a while, you'll get used to 60 squared being 3,600, and you can write that instead. And the calculator says 7,289.
I hope.
I got a question. The number of 60s, is that 24?
Oh, 20, yes. So this probably changes a little bit?
Yes.
8,055.
That is totally my fault. Let's say I did it on purpose to see who's
Testing
paying
us.
attention. And she just went along with it. So it's not the same as Roman in terms of answering, because I can't look at this and just write down the answer. There's some calculation involved. It's a little bit more, I dare say, sophisticated. It's a little bit different in that sense, that it's not visually just rewrite immediately. I do have to do a little bit of work. Any questions on this kind of conversion? Now the empty place can occur anywhere. Let's look at 3,610. How would I write that in Babylonian? Break it up. Can I fit a 3,600 in here?
Yes.
1. 3,600, which remember is 60 squared. How much is left? You can keep track of how much is left. There's only 10 left. I can't fit a 60 in there. So there are 0 groups of 60, and 10 will be left. So in this case, I can't forget this empty place. Because if I just write down 1 space 10, what am I writing down there? What is that number?
70.
That is 70. And that's not the number I'm representing. So let's see here, but this is 70. So it should be, I have to show that empty place. To show that it is, all right, do this. It is a 3-place number. Those look like little tens, so let's just emphasize them. So now I see, okay, there are 3 places. I count 60 squared, empty, 10. Any questions on that? Okay, let's do one more Babylonian to decimal. What is the decimal number that I have there? Again, not the number, the calculation first. There's a step for me in between this and the final answer. So I see 3 places. So I'm going to count 21 groups of 60 squared. And if you count from right to left, this is the 0 place, the 1, the 2, and so on. 2, 2. Then I have 7 groups of 60, 60 to the 1, if you want to. And I have 42, essentially times 60 to the 0, but that's just 1, so we don't have to write that. And what do I get? Anyone have an answer?
76,062.
20?
What?
I just couldn't hear the first one.
76,062.
Anyone confirm that?
Yes.
All right. So that's half of the questions you have to be able to do. It's not so bad. You do a few of those. It's easy. Very manageable, I think. And again, we're not doing strange historical number systems, strange relative to what we have today. I want to focus on the ones that have relevance to our modern time. Before we do the other conversion, I claim we still see the Babylonian system every day. You see it every day of your life. Where? Where do you see it? You saw it this morning when you got up. On a clock. Hours, minutes, seconds. If I have, for example, this 76,062 seconds. How do I figure out how many hours, minutes, and seconds that is? This is exactly how. There are 3,600 seconds in an hour. So I see how many hours do I have? 21. Something's left over. 7 groups of 60 means 7 minutes. And then 42 is left over. And if you go bigger, well, it changes that a little bit. Only the 3 places are similar. If you go one step up, then it changes to a 24, which is not quite the same anymore. But still, in a small, on a small scale, this is exactly the Babylonian system. So we still have some connection to what they came up with so long ago. Now, the other version, the other question is converting a given decimal number to Babylonian. Random number time.
6.
I want something in the high tens of thousands.
18,735.
That's your favorite number?
Yeah.
All right. What do I do? I need to find the biggest power of 60 that can fit into this.
Nope.
What is 60 cubed? I honestly don't remember. We'll have to find it. What is 60 cubed?
216,000.
All right. That's too big, right? So that's out. So then I can go 60 squared, which I know is 3,600. So I simply have to divide this by 3,600 to see how many 3,600s can fit in there. So when you do 18,735 divided by 3,600, you're going to get potentially a decimal number. You just throw the decimals away, because that's the remainder that I'll figure out later. what do I have here? How many groups of 3600 can fit into that? 5. So then, up to this point, I've used, how much? What is this? 5 times 3600? 18,000. So I still have 735 left. How many 60s can I fit into 735? 12. Then I've used, of this 735, I've used 720. I have left 15. So it's a little slower. I do need to break it up in terms of these 60s. And then once I do, there are my places. Let's write that over here. So 5. Space 12. Space 15. And there you go. So you do have to be careful that you break this up correctly, and then you convert each one correctly as well. Questions? Does it make sense? It's hard for us because of the 60. But try and imagine that to them, 60 was as natural as 10 is to us. That's all they knew. They didn't know anything else. They came up with it. This was their natural tendency for a number system. And growing up, that's what you learned. They've uncovered clay tablets that were homework assignments of kids, showing all these calculations. If that's all you know, and that's what you grow up with, it's as natural as anything else. Questions? Should we do one more? Let's do one.
Yeah.
All right. New random number. What's your favorite number?
80,412.
All right. Now, what did we say? The 60 cubed was still too much, right? That was 216,000. It's too much. So again, I'm going to have 3 places. I'm going to fit in as many 3600s as I can. How many in this case? Let the calculator do that. Yes, I can do the long division. No, I don't want to.
22.3.
22. Can anyone confirm the 22?
Yeah.
All right. So then, 22 times 3600 is how much I used, which is?
79,200.
79,200.
So I have a little bit left. Not that much. 1,212. And that is clearly too small for another 3,600. So you do have this check that I have something left. If this is bigger than 3,600, that means I could have fit in more. But it's not. So of the 1,212, I have to fit in as many 60s as I can. How many 60s go in there? 20. 20 times 60 is 12 with 2 zeros. And I have left 12. Clearly that's too small for another 60, and that is what's left. You can write here whatever you want, right? As long as you keep track of it. Doesn't matter what you write. I'm interested only in this breakdown and then the conversion. So I have a three-place number again. 22 space 20 space 12. In some places, if you research this, they'll put the empty symbol here to emphasize no ones. I'm not the biggest fan of that. I think the space is sufficient to indicate a new place. So let's not worry about that. There you go. Babylonian numbers. I say again, very important, you have to review Roman and Babylonian because tomorrow we are doing arithmetic in both. It is fine.
That's the homework for which is the additional examples.
Whatever the additional examples is, only the conversion. It should be in section 2.2. Yeah.
Are you making sure there's nothing outside?
No, that's it. It's only two kinds of questions you have to be able to do. Only two. Look very small. It's four one. Look at these.
So I was looking at the course breakdown, like for the grades, and also like
I know it.